So the next sort of steps of modularity, or the next tenets of modularity, are information hiding and data encapsulation. And both of these are really just ways of abstraction and importance of abstraction. So the first one is information hiding, and that is you hide the complexity in a black box. Remember when we were talking about abstraction, and we were talking about how you can take it from machine language and bring it all the way up so we can do higher level things. Well, that's what information hiding does. It hides the complexity in a black box. Each one of these is a black box that hides the complexity. When you write stuff for assembly language, you're using things that this language down here, the machine language, expose. Some APIs, some commands, some functions. You're using this code to build this. And then with assembly language, you create a new set of functions, controls, and commands, which this next language will bring. Once this next language is done, you create another set of codes and commands, and then Java, on top of that, will start calling those codes and commands, which will call those codes and commands, which will call those, which will do things like move memory around. So with this over here, what we're trying to do with information hiding is hide that complexity in a black box. We can do this with things called like functions, macro, library, classes, method. These are all just the technical terms that we use whenever we're programming. But let's say that we have a proper black box right here and another proper black box right here. And what they are is an encryption device, encryption, and then a decryption device. So if, for example, we put in 35 here and it comes out with, I don't know, TY62. So that's the output. And then now we take TY62 and put it in the decryptor and it comes out as 35. Do we need to understand how it's encrypting and decrypting to be able to use these two boxes, to be able to use these two programs? No, not at all. All we need to know is what is it input and what's it going to output. And we are completely and totally fine with using it for all of its purposes. The internals are not needed to be known, and that's very important. That's something that's very helpful whenever we're designing programs, especially with, let's say we're designing a program for let's say a car manufacturer. We have all this code that maybe self-generates code in the background. Let's say that it's a self-driving car or something, but we're not car people. We don't understand what cars are supposed to be made like. We don't understand how it's all supposed to be programmed. So what we do is we program a set of buttons, a set of tables and switches and stuff on sort of like a little control panel right here. And with this programming, we then abstract out all of the nitty-gritty of actual programming, the for loops, the while loops, the functions, the macros, libraries, classes. We abstract that all out, and we allow a technician to just press buttons and enter in values, and then our code will do the rest. So we have sort of given the automobile engineer more control. We've given them the power to use our code with their stuff. And that's the importance of information hiding, is it allows more and more complex things to be built. It allows you to sort of create a foundation and then build on that foundation and keep creating stronger and stronger things over time. And that's how programs are getting more complex over time, is that we're slowly getting better at this abstraction and going more and more. But information hiding, it's the idea of hiding complexity in a black box. The next one is something called data encapsulation. And this, you'll notice these are actually pretty close. This one is sort of information hiding, while this one can be known as data hiding, so they do have a relationship. But this one is all about hiding the implementation details from the user and only providing a set of tools to manipulate the data. What we mean by this is, let's say we have a class right here, and one of its variables is, let's say, transaction data. So maybe the amount of money. So we put transaction here. Now, why would we need to put a get function and a set function? Why don't we just have, let's say this class is named banking. Why don't we just allow maybe this program over here to call something like banking.transaction equals 50? Why don't we just allow that? Why don't we allow this to make a direct call to transaction? Well, this sort of breaks the idea of data encapsulation. If we do this, then suddenly our data can be manipulated in any way, shape, or form, and we don't have any control over it. We can't prevent the user from inputting invalid data and screwing up not only our algorithms, but maybe the entirety of our database. So with data encapsulation, what we do is we create these getters and setters. So if over here we want to know what the transaction is, it calls the get. So it would call the get, and then the get function would return the value. This get function can be very important because maybe it has a layer of authentication on it. Maybe it has a layer of authentication. With that, that means that a password would need to be input before this class gives out data. And that's very important in the banking world. You don't just want people to be able to program things and grab directly off the server anything they want. So a getter helps protect in that. And then a setter is a lot of times more important. The setter will prevent us from doing certain things. So we'll call a function to set. Maybe we say we want to set the transaction to -50. Well, the setter is going to have just a simple little if statement in here. If, less than 0, return. So if less than 0, return, I don't know, error. Something really, really simple, and this is a less than symbol. Less than 0, return error. And why is this important? Well, if we're doing transactions and we keep charging people -$50, well, we're going to actually start getting money, aren't we? And that's a problem. We don't ever want a transaction to go below any money, because then instead of it charging our account, we're actually just taking money from people. So a simple setter would add another security layer there as well, and would also protect the integrity of our banking in the sense that it can have more checks in here, and we couldn't deposit, say, $1 billion by accident either. There might be an upper end that potentially escalates it to like a manager or something. But overall, the idea of data encapsulation is sort of protecting data, making it so we only expose this sort of set of tools to manipulate the data instead of just allowing data to be accessed and changed any way, shape, or form that we want. And so with good software design, we think about that data encapsulation as well. We think about why are we just letting people just grab this data? Why don't we make a getter and a setter function? Why don't we protect it in some way or create a whole class that deals with this sort of thing to protect the integrity of our database?